and thank you for joining us for our third episode of the Fire Strong podcast. Fire Strong is an official podcast of the Fire Center of Excellence and Fort Sill's Public Affairs Office. I'm your host, Don Herrick.
And I'm Keith Pinnell.
And today in the studio, we have our guest, Brigadier General John Rafferty, the director of the Long Range Precision Fires Cross-Functional Team. Sir, thank you for joining us today.
Thanks, Don. Glad to be here. Great opportunity to communicate with our big community of supporters.
So we really appreciate you coming out today, and we always like starting off these podcasts by asking a little bit about yourself and your background.
Yeah, thanks. So I'm John Rafferty. I'm currently the director of the LRPF cross-functional team. I've been the director for about the last 3.5 years, and it's kind of been a blur, but it's been a fantastic opportunity to live here in the Lawton Fort Sill community, which Tracy and I have really grown to appreciate. I started here at Fort Sill for Officer Basic Course 1-93, and really didn't come back until we got stationed here 3.5 years ago. So for us, it's been a great opportunity to learn a little bit about this part of the world, and certainly appreciate a very strong Army community here at Fort Sill, and great partnership with the local community in Lawton. I enlisted in the Army in the late '80s and served a couple years as a mortarman in the old 8th Infantry Division in Germany, and then got out and was in the National Guard and used the GI Bill to go to community college, and then graduated from Longwood University in the ROTC program, which was an extension of the University of Richmond. And both Longwood University and the University of Richmond both made March Madness this year, so it's very exciting for me and hard to concentrate on anything at all this week except for filling out my bracket. But I think I'll manage to get some other work done too.
That's awesome.
And over the last better part of 30 years, I've had a great career that has taken us all over. I think primarily my operational field artillery experience has been in airborne and Ranger units, and I've had the opportunity to serve overseas in Germany on a couple occasions. A few exchange positions with the Marine Corps to attend their captain's course called the Amphibious Warfare School, and then attend the UK Joint Command and Staff College, and then a couple of short assignments in Washington D.C. and Army Legislative Affairs, and then the XO for the Director of the Army Staff. And so when I came here for this position as the director of the cross-functional team, I actually didn't feel unprepared, even though I didn't know anything about engineering. I didn't know anything about science and technology. Didn't know anything about Army acquisition. But what I do know about is field artillery and fire support operations. Requirements from the field and warfighting, and that's exactly what we're supposed to do here in the cross-functional team is meet the needs of the warfighter in the field, and develop requirements and hold people accountable as we work on developing those systems and capabilities for soldiers and leaders in the field.
Sir, you mentioned it now a couple of times, cross-functional team, and I think a large part of the force don't exactly know what a cross-functional team is. So in a nutshell, can you explain the whys and wherefores and what's a cross-functional team, and specifically as it relates, what is LRPF?
Yeah, so I'll start with that's a great question, Keith. I'll start with the cross-functional team part. If we go back in time about 4 years to the beginning of the cross-functional teams, the Army was developing a new operational concept called multi-domain operations that was based on the threat. And our adversaries in China and Russia have been investing in various systems that counter some of our advantages. They've watched us fight and watched us operate over the last 20 years in Iraq and Afghanistan, and they were investing in areas that counter some of our distinct advantages. And then if you looked at the Army system for modernizing, there was nobody that was really in charge of it. Yeah. You couldn't raise your hand. It's the Army senior leaders couldn't ask who's in charge of modernization? Raise your hand. And you'd get TRADOC would have a portion of it. The Army acquisition side would have a part of it. But no one single commander in charge of it. And in a nutshell, that was the light bulb moment for Army Futures Command. Let's put a commander. Let's follow our own warfighting doctrine and have unity of command. And let's put a commander in charge of modernization, because we know that we, as the chief says, we have one chance in a generation to modernize. We can't screw this up. So put a commander in charge of it. Now, if you take that down to the modernization efforts, as the Chief of Staff of the Army designated the modernization priorities, you need to put somebody in charge of each of the modernization priorities. And cross-functional teams are really a best practice taken from industry, and in which you have a cross-functional team that's focused on priorities of the senior leaders, that has the resources and the access to the senior leaders to maintain momentum, to maintain emphasis, and to get results. What the C and cross-functional team, or CFT, the C is not for command, as I like to say, and it's not for checkbook. So my job is to be responsible for this stuff, but I don't have all the authority. So we just got to work hard as a big team. We're unified by the purpose, supported by the emphasis placed on it by the Army senior leaders, by the resources that they've put behind it, and our job is to get things done, to work as a big team. My experience as an artilleryman, especially as a fire supporter, means that I'm comfortable with multiple bosses, and I'm comfortable often as an informal leader, getting people unified by purpose and getting results. So the cross-functional team has about 25 people here at Fort Sill, but our teammates and the people really getting the job done are our teammates from Combat Capabilities Development Command, called DevCom. So DevCom in the Armament Center at Picatinny Arsenal, the Aviation Missile Center at Redstone Arsenal, and the Ground Vehicle Systems Center in Detroit Arsenal are our primary, Army engineering partners. We have acquisition partners from Program Executive Office, PEO Missiles and Space at Redstone, PEO Ammunition at Picatinny, and PM Self-Propelled Howitzers at Detroit. So those are kind of our primary, heavy-hitting partners. We got a lot here at Fort Sill too, from the Doctrine Department, from the CDID, the Capabilities Development Integration Directorate. The Field Artillery Commandant and his team are very big partners in this, and then we have a whole bunch of industry partners that we work with that really I'd like to take it one step further and say that they're industry teammates. And as you can tell, not every single organization that we pull together our interests are not exactly the same. But our job is to keep them aligned in the same direction to get the outcomes we want. Focused on delivering capability to the hands of soldiers. So that's kind of how the cross-functional team works. Is just to keep people focused on the objectives, hold people accountable for delivery, and to get results. To be responsible for this stuff. What's LRPF? So LRPF is Long Range Precision Fires. That's the Army's #1 modernization priority, and it covers a lot of things. It's not just bullets that go farther. It's also the howitzer that serves as the platform for firing. It's longer range missiles, but it's also working on deep sensing. And targeting at ranges that we haven't ever before. It's fire mission processing at speeds that we can't do it now to meet the demands of large-scale combat in the future. So it's really kind of an end-to-end mission. The LRPF may sound like it's just bullets or missiles, but it's not. It's as much about finding the targets and processing the missions as quickly as we can in order to get those munitions on target in a timely fashion. That's a long answer to your question.
That's great. Thank you.
Well, that's exciting. I mean, working with team members all across the country for that one purpose. So, as a retired field artillery guy, I'm always excited to hear about the new developments that we have from the field artillery. So, can you tell me some of the highlights that you've accomplished in the LRPF, sir?
Yeah, so we've got a couple of refer to as signature systems, but I'll start with the self-propelled howitzer modernization that we're doing. Right now, the Army is our primarily fielded self-propelled howitzer is the M109A6 Paladin 155 millimeter self-propelled howitzer. That was introduced to the Army when I was a student here at in Officer Basic Course 1-93. I just remember the 1st Battalion being delivered to a unit here at Fort Sill, and it being a big deal for the Army. And right now we're going through an overdue upgrade to those howitzers, to take it from the A6 to the A7. And the A7 is fundamentally a waist down upgrade. So it's a chassis upgrade that addresses automotive performance issues, survivability, and mobility. So it's absolutely essential to keep our fielded force with the same maneuverability and survivability as the units they're supporting, and to get a degree of commonality across chassis, improve readiness and availability for the fielded force. But it doesn't do anything to get us more range or lethality. So that's where the extended range cannon artillery system comes into play. ERCA. We're going to work on a longer term name for that system. That's
figure stocks.
yes. There's a lot of things that in our portfolio that are classified, but the future name of that system is among the most closely guarded secrets.
As it should be.
Yes. So that'll come out at a later date. But the ERCA system is just that. It's the howitzer upgrade. It's the supercharged propellant. It's the long range projectiles, and it's course correcting fuses to get accuracy and lethality at ranges out to 70 kilometers. So really going from about 35 kilometers out to 70 kilometers. Wow. So really almost doubling the effective range of our self-propelled howitzer fleet. And I'll tell you how we're doing it. So the talking about the upgrade to the self-propelled howitzer, we're modifying the cab. So the current cab that's on there is basically being modified to accommodate an upgraded armament system. Armament system is everything from the recoil to the end of the cannon. So this upgraded armament system has a sliding block breech. So going away from what we have now is the interrupted screw breech that we close and then it turns to seal. We put a small primer in the back of it to begin the explosive train. The new sliding block breech is a lot more like a tank breech. It slides from the bottom to the top, provides the seal, and then it can be fired electronically using what we call a stub case on the inside. The rest of the gun tube is it's going from a 39 caliber length gun tube to a 58 caliber length gun tube. So caliber length for the artilleryman listening is, as you know, caliber length is an expression of, caliber length is expressed in multiples of bore diameter. So 155 millimeter is about 6 inches. 6 times 39 is about 20 feet. 6 times 58 is about 30 feet. So 58 caliber gun tube is about 10 feet longer than our currently fielded gun tube. And when we're also getting rid of the bore evacuator, which has served us very well, but has become with the current max propellant has become something that's difficult to clean and difficult to keep serviceable. So we're getting rid of the bore evacuator. We're using something that's called a scavenger, which pushes the toxic fumes out the front end of the gun tube, and this, like I said, upgraded armament system coupled with supercharged propellant. Supercharged propellant will get us muzzle velocities in excess of 1,000 meters per second with a rocket-assisted projectile gets us 70 kilometers. Now, also for the artilleryman out there, we know that probable errors in range at 70 kilometers are in the hundreds of meters, right? So we have to have a course-correcting fuse to have accuracy. And so we're upgrading the currently fielded precision guidance kit with a different model, different industry partner to get us the accuracy at range. So that's one component of this, which is a high explosive rocket-assisted projectile. We've also taken what essentially is currently fielded Excalibur with a software change and very deliberate engineering path. We've been able to push that to 70 kilometers as well. We had a 70 kilometer target hit with Excalibur a little over a year ago, and so we're confident that that'll be one of the projectiles out there at 70 kilometers, and then so that's. Back up for a second to say that our approach to IRCA as a system, in accordance with the guidance from the senior leaders, is improve the range and lethality. Right, let's maintain overmatch with range and lethality, and then let's work on the rate of fire. But range and lethality primarily there. So with that rocket assisted projectile and with Excalibur, we've got the range with accuracy. Now to get the lethality that we need against heavy armored vehicles and artillery under armor is with the replacement to DPICM. One of the components of DPICM replacement is called cannon delivered area effects munition armor, and we're going with a hit to kill projectile that's based on the current Excalibur, that will be target seeking at ranges with the shape charge. So we'll get the tank killing, the self-propelled howitzer killing effects that we need at those extended ranges. So what does this do, right? This fills a gap. When we start our development process, we ask ourselves one question: should we do it? And in this case, the should is absolutely. The threat is pacing, and enemy investments in long-range cannon artillery and long-range rocket and missile artillery demands that we've got to maintain our ability to conduct combined arms maneuver, and that's what IRCA will allow. And then the second is, does our operational analysis show us that this is an important investment? And it absolutely does. In all our most challenging warfighting scenarios, when we introduce IRCA as a general support division level artillery battalion, that gives the division commander the ability to shape the brigade combat team close fight by killing enemy long-range artillery and maneuver forces. It's when we start to win in our most challenging scenarios. So the should we do it is the answer is absolutely yes, and we feel very good about it. We're going to deliver a battalion set of this to a unit in 1st Armored Division. We were just there last week setting conditions with them, and what we intend to deliver them is for a year-long operational assessment. We're going to deliver this stuff in the 4th quarter of fiscal year 23. So really, we'll start next summer. So about 15 months from now, we'll have draft operational doctrine. We'll have draft sustainment doctrine, because we know this is going to be an additive capability in the division. Is going to require a lot of logistics. So how are we going to fight this thing from a logistics standpoint is equally as important. And we're going to deliver we've developed the firing tables that they're going to need to take them from section all the way up to battalion level qualifications. Howitzer section crew drill for a different system and different projectiles, for the maintenance tasks that are going to need to be accomplished by individual and collective teams, and a few other items that really make up a training packet. So we know a division starts planning, more than a year out. So it was important for us to get there last week with as much of this information as we can, so they can begin to develop this training plan, so we can assess the operational concept, the sustainment concept, and then really stress the equipment, the howitzer, the projectiles, the propellant, in a relevant environment. And there's no more relevant environment than 1st Armored Division at Fort Bliss and McGregor Range and White Sands Missile Range. So we'll get good feedback for that year. So that's the IRCA system. I'll just take one step up and talk about the Precision Strike Missile.
Mm-hmm.
That's our replacement to the Army Tactical Missile System. ATACMS developed in the 80s. It's 1 missile per launch pod container. That means 1 on board a HIMARS or 2 on board an MLRS, and it costs about $1 million a missile. In order to keep those missiles in service, we do something called service life extension programs, and the service life extension program costs about the same as it does to make one. They take the missile apart, they put it back together, and you get another 10 years of service out of it. So sometimes we've paid for those missiles 2 or even 3 times. The Precision Strike Missile has a range beyond 500 kilometers. It has the same lethality as ATACMS. It fits 2 missiles per launch pod container, so that'll be 4 on an MLRS or 2 on a HIMARS, and it costs about the same. So it's really a no-brainer for us. The best part about it is it's really exceeded our expectations along in development. We've got a great government and industry team working on this Aviation and Missile Center along with our industry teammates, and we're going to deliver the first set of missiles through an urgent material release next year. And there's no real obstacles to that. We've had very successful tests, and because of that, we're already working on integrating taking our science and technology investments on integrating a seeker, so it'll go to being target seeking from coordinate seeking. And so we had a successful seeker test just a couple months ago out at White Sands with that seeker integrated into a surrogate missile. We've got a few more test events for that before we start to integrate that into the PRISM missile. And then we've already had somewhat of a breakthrough in range extension using a different propulsion technology. That's got a couple years to go before it's ready. But we know that we can take this precision strike missile much farther than 500 kilometers, and then that's where we're convinced. Back to this, should we do it? We know what our adversaries have invested in long range missile fires. And we know that the best way to create a dilemma for them is when the precision strike missile, both in its initial capability and then its extended range capability, when we can have that distributed across all of our launchers. I mean, we have hundreds of HIMARS and MLRS launchers in the Army fleet. That creates a dilemma when they don't know which launchers are loaded up with short-range rockets or which ones are loaded up with PRISM or which ones are loaded up with extended-range PRISM. It puts so many of their target sets at risk that's the dilemma. For large-scale combat, that's what the Army has to have, is things that can scale across our entire fleet. And while onesies and twosies of purpose-built systems to get at a niche capability are important for competition. For real large-scale warfighting, we need the stuff that can be in any of our launchers across our entire formation. So those are our real signature systems in the long-range precision fires cross-functional team that are gonna be in the Army next year.
Oh, that's exciting.
Wow. Good. Real quick, it's not just flying objects. One of the most fascinating, perhaps paradigm shifting programs we're working on is bringing cloud computing to field artillery. That was a question. Sorry,
You're right.
I didn't phrase it. That's a question. So we're enhancing our programs, our targeting programs. Is that what I'm understanding?
So there's a whole range of efforts underway. A couple that we're leading, a couple that we're teammates and supporting, that have to do with sensor to shooter, and increasing our responsiveness from deep sensing all the way to firing howitzers or rocket missile launchers. So you're right. One of the most exciting parts is taking advantage of cloud-based computing. In some ways, it requires a little bit of a leap of faith, right? Because we have to believe that the Army is gonna deliver cloud to the edge. And I'm aware of the efforts that the network cross-functional team is leading with that, and so we can't wait on them to have that perfectly figured out yet. We got to figure out how we're going to fight with the cloud now, so that we're ready when that's there. And one of the going back maybe more than 2 years now, I was in a participant in a fairly high level Army board on command and control systems.
Yeah.
And one of the more senior folks in this board sent me a message on Microsoft Teams as we were having this meeting. I think it was sort of at the beginning of COVID, and as you're all learning how to use Microsoft Teams at the time, and the question was, "Hey John, what do you think about AFATADS as a tactical cloud pilot?" And I thought, that's really exciting. I don't know why I love it yet, but I should, and I'll get back to you. And so I called one of my more savvy teammates, somebody I'd known for a long time, and said to Rob, I basically asked him the same question. He goes, "What do you think about as a tactical cloud pilot?" And he said, "John, what do you mean? Do you mean cloud as a noun or a verb?" Right. So it showed how little I understood the environment. Had a lot to learn, but I sat down with our folks who in Army Futures Command who do systems architecture, and had them really lay out what our really fire support system and fire control system architecture diagrams look like, and started to see what I guess I always sort of realized was we have a lot of vulnerabilities in our system. AFATADS now, and AFATADS as it's modernized to 7.0, is an amazing capability for our Army. We've come a long way on AFATADS. I remember when it was introduced to the Army, and was it was a real challenge to make the transition to AFATADS. But 7.0 is going to be far more intuitive and a great step forward for what already is an amazing capability. But even though we set controls in our AFATADS at various echelons, so that it can the mission can stop there to be processed, or it can just flow right through to the next stop. And so there don't need to be intervention points at every stop. But the point is that mission still has to flow from one to the other to the other to the other to get down to the platoon FDC, and that really does provide that there are some vulnerabilities associated with that, especially when we're talking about the future of a degrade or denied environment. So jamming, large scale combat, and so high likelihood that fire direction centers could be affected by counterfire. One could be moving, survivability move, and so you're not necessarily going to have this ease of missions flowing through. And so if we're able to take advantage of cloud in certain instances, then we can bypass some of that hierarchy and get more of a burst type of transmission. Doesn't mean people still don't, and organizations still don't do their jobs, but we're getting closer to this idea of which is central to future warfighting of any sensor best shooter, and not held hostage by a hierarchy that missions have to flow through. So the cloud is one way in order to address some of those. What we found going into it with really that narrow of a focus because if we're going to do this, we want to make sure it increases it improves our combat capability. But then there are also all sorts of other advantages with cloud that really go across the 5 requirements. Better access to meteorological information, ease of changing org for combat. When we do high-level simulation exercises, we very routinely will take an artillery battalion and say, hey, you are no longer DS to 2nd Brigade Division X. You're now reinforcing Artillery Battalion X for Brigade Y. And we make those changes very seamlessly in our higher level simulation exercises. But we know in practice that's a very challenging process in our fire control systems that require really savvy operators to be able to do that pretty quickly. If you can, if the information that's needed is available in the cloud, that can happen much more quickly. And we found some of that. What we found is that we were pushing on an open door with the field, and cloud experimentation has taken off like wildfire in our army. We can't keep up with the field. Yeah. They're way ahead of us already. We thought we were being pretty clever here on the 3rd floor of Building 475 and in developing a strategy here, and we engaged the field on it. It was okay. Yeah, let's try that next week, and then all of a sudden, there must be 5 or 6 divisions that are already doing it in 2 corps, and now we've got it got forward in theaters, and so it's exploding, and so we're they're going to tell us how to exploit this. So I feel very exciting. I think you're right that the use of cloud computing is really very exciting.
It sounds like a very exciting time to be in the field. So what would you tell a soldier in field artillery about modernization and pursuing a career with Army Futures Command and LRPF?
Well, the best way to support Army Futures Command is be open to experimentation and like I said, believe in the future, and we can't wait. We can't be sequential about this. We can't wait for the Urka howitzer to be built before we start making projectiles, as an example. We got to do these things concurrently. We can't wait to develop projectiles that attack targets at 70 kilometers until we have our targeting and deep sensing perfect for 70 kilometers. Because we can't. We got to believe that space-based proliferation of space-based capability is going to help us find targets deeper than we can right now. That data centricity, so data available to us, is the key to us finding targets. Not, platoon leader directly tasking a satellite. We just need the data, and we can go find the targets in that data. We can't wait on that data being available to start working on the tools that are going to help us exploit the data. And I'll give you an example there of something we're doing with the intel community, which is one of the most remarkable changes that I've seen in my time in Army Futures Command is the partnership between the field artillery and fire support community and the intelligence community to target. Not necessarily just limited to intel support to targeting. The intel community is talking about targeting. Let's find targets for the artillery units to attack, and that's a pretty dramatic change in terminology. And it's not limited. It's not just words. It's backed up by actions. So the intel community is developing something called Titan. Titan is a ground station that'll be, when scaled properly, it'll be anywhere from brigade up to corps or even theater level headquarters. This ground station will ingest data from space-based, altitude, high altitude sensors, and terrestrial sensors. So ground-based sensors that include radars, but not limited to that. Other sensors that are being developed by the Army. So it'll be this big data repository. It's driven by collection priorities, and collection priorities usually match up with targeting priorities, right? That's the whole point of that kind of fusion. And we're developing FIRE's application for this Titan ground station in great partnership with Titan. It's called SHOT, Synchronized High Up Tempo Targeting. It's powered by, it's driven by the high payoff target list. So the commander's high payoff target list are these targets must be attacked in order to enable the scheme of maneuver. The second part of that is the attack guidance matrix. The second part of that is the target selection standards. If I find this target and it meets these target selection standards, it's this accurate. It's the data's this old. There are other categories of target selection standards. If it meets the target selection standards, then I follow the attack guidance matrix. Attack guidance matrix says, what am I going to shoot at it? And that application is powered by a couple of what I refer to as artificial intelligence engines. These engines find the targets in the data, and those algorithms are already being trained every day by our partnership with Army G2 and other intelligence agencies. We're going to have into next year this real capability that we'll start delivering to the field. It already works through Army experimentation and the sensor to shooter campaign of learning and Project Convergence. We've already been training these algorithms and working these systems. So what we have to do is we can't wait until we have the platforms and the intelligence to start figuring how we're going to target, right? So it's a degree of concurrency, right? Simultaneous development and action and trust across a big modernization community to deliver these capabilities. So back to your question about what do we want the field to do? We want them to believe in the future. We want them to believe in Army Futures Command and the cross-functional teams and the capabilities we're going to develop, and we need them to be ready to exploit that capability when we deliver this.
So, Sarah, we're running short on time, so I just wanted to open it up to you on any messages or thoughts that you wanted to share with the force.
Yeah, I'll finish with three things that the former commander of Army Futures Command gave to us in writing, and it was and they're very simple, but have been very important for us in our approach to modernization. And the first one, he says, is winning matters, but winning together matters more. And that is really significant for us because as a big team, the cross-functional team here at Fort Sill doesn't win anything by itself, right? So we, if you just look at the extended range cannon artillery system prototypes that are being developed, we've got 5 on the ground out at out at Yuma Proving Grounds. We'll have 18 of them next year. They're in very rigorous swim lanes of testing. But in order for those howitzers to get delivered, it starts with the M109 A6 Paladin howitzer. It's the chassis is upgraded to an M109 A7. That's done by an industry partner and finished right here at Elgin, right up the road from here at BAE Systems. And then the cab is modified in the Army at Anniston Army Depot, finished at Letterkenny Army Depot in Pennsylvania, and then the gun tube is manufactured at Watervliet Arsenal and assembled at Picatinny Arsenal, and then just delivered to Yuma Proving Grounds. And so it's a big Army Futures Command, Army Acquisition, and Army Material Command. Big win to put these things in the hands of FORSCOM soldiers, supported by the trade activities here at Fort Sill. So there is no bigger win in the Army than what we're doing. So winning together matters enormously for us. And so that the team building that we do on a daily basis is probably our most important daily task. The second thing they told us is that it's got to be the intersection of technology and concepts, and that's pretty powerful too. And beyond 2023 and beyond what we're delivering for the Army of 2030, we've got to get our folks who work on concepts and our technologists working together. So we've got technology-informed concepts and concepts-informed technology. And so really get into this virtuous cycle of our people thinking about how we're going to fight in the future, informed by what's possible from a technology standpoint. And so we don't end up pursuing what is a term used in this business called unobtainium. We aren't pursuing fantasy. That we're pursuing in the future is entirely feasible from a technology standpoint. And so like I said, we're laser focused on what we're delivering in 23, but we're thinking about the future, and that technology informing concepts is a really important approach for us. And then the most important thing that we do here on our team is soldier centered design, and soldier centered design means that the soldier and the warfighter's input is incredibly important in the development of these future capabilities. So soldier touch points is the term for how we get this kind of feedback, and they serve a couple of important purposes. One is inform the requirements writing process. The requirements are the technical documents that help us go to our industry partners and our government partners to build something, right? And so informing those requirements is really important. But beyond that, it's help us with the design. So let's get a howitzer section chief in the back of the IRCA howitzer to help us configure the inside of it right. Is this better here or here? Does this switch work better here or there? And get real, soldier feedback, and that exchange between, soldier, leader, cannoneer, and engineer is incredibly powerful. And every time you see it happening, you realize we can't do enough of these things to get it right. So, and then the last thing is how are we going to fight with these things? How are we going to develop the crew drill? Take it up a notch. How are we going to fight as platoons, and then take it up a few more notches into our, high-level warfighter exercises? Is how are we going to fight and win with this capability at the division level? How are commanders and staffs employing it? How are sustainers providing logistics that it needs? And so that soldier-centered design is beyond the placement of switches. It's how we're going to fight with this system. So I just want the force to know that you're the centerpiece of Army Futures Command's approach to modernization, and then the centerpiece of the design and engineering as well.
Sir, that is awesome. Once again, we just want to thank you so much for coming out today and joining our conversation. And for everybody out there, we just want to say thanks to our guest, Brigadier General John Rafferty, the director of the Long Range Precision Fires Cross-Functional Team. And you've been listening to Fire Strong.